Hello everyone, welcome to IMS Gate Academy. I am ATUL and I welcome you all in this foundation course on theory of machine subject. We have started our theory of machine in which we have started with the first chapter, simple mechanism, where we have discussed about kinematic link, kinematic joint, kinematic chain, and then finally we talked about the mechanism part. That basic understanding fundamental parts we have already discussed. Now in the last session we have started our velocity analysis, which is what the part of a kinematic analysis, where we need to understand what are the velocity, what are the positions, what are the acceleration of a link in a given mechanism. Right, so in the last session, velocity approach, velocity analysis, we have talked about velocity diagram. We have understood the concept of velocity diagram and we have seen some cases also. And I have given one numerical also in the last class, right, as a homework. So that numerical we are going to solve today, and we will solve some other PYQ questions as well, right. After solving those questions, we will move to the second approach of velocity analysis, which is the eye center method, right. So there are two methods already I have discussed: velocity method, velocity diagram method, where we will be using relative velocity concept. Second is the eye center method. Both the methods we will observe, we will solve some questions in both the ways. Method first basically, that is relative velocity method. Second method is eye center. Both the methods we are going to use in order to solve any of the PYQ questions, so that you can have a complete clarity that which method I want to use, in which method you are more convenient, right. So in that way we will be solving questions with both the approaches, right. So guys, I've told you also, good evening, very good evening Matan, audio clear, yes, mechanical world, very good evening. So as I already told you, if you have any doubts, any confusions you are having in any of the topic of theory of machine, guys, you can mention in the comment box. I will definitely do one session, one live session I will be going to do in those topics in which you want, this topic is difficult for us, definitely I will take one live sessions, no matter whatever the topic is there from the GATE syllabus of theory of machine subject, you can mention. I will do one live session on that, and we will see some numericals also related to that particular topic. So always welcome from your side. Any suggestion comes, I will definitely do one session, right. So let's get started, guys. Now please, this is what the Telegram group link I have provided here, and in the description also you can join this particular Telegram group, where you will be getting all the latest job notifications, daily quizzes you will be getting, which will definitely help you in your GATE exam preparation. And apart from that, whatever the YouTube events that we are going to conduct, you will get all the information there, every details will be there in this Telegram group. Apart from that, YouTube live lecture PDF also you will be getting there. So I will suggest that everyone should join this Telegram group, right. And one more thing, we have started our live online GATE program, where we are taking more than 800 hours of live sessions, which are completely interactive, which means in the class itself, in the live class itself, you can ask the doubts with your faculty, right. Directly you can ask the doubts in the live class itself, so you will never face any issue that in the live classes you are not able to interact with the faculty, or only you are able to message, only able to chat. No, directly audio interaction is also available there. You can interact with the faculty, right. Apart from that, mentorship sessions will be provided for every student, where he will be discussing one-to-one with the faculty regarding his preparation strategy, or he might be facing some challenge in the GATE preparation. Everything will be discussed one-to-one with the faculty. So that is the unique feature in the IMS GATE Academy live program, right. Apart from that, you will be getting doubt solving portal and exercise book, theory book, and GATE previous year booklet you will be getting. And online test series is always available, where you will be getting chapter test, subject test, multi-subject level test, and finally mock test. So these are the IMS GATE Academy live online program features. And if you want to understand more about this program, you can directly call on this number to have a free counseling session, where our counselor team will be helping you regarding all the admission process, everything. You can directly call on this number if you want to take the admission in your GATE preparation program, online program, right. So now we can start our session here with the topic of velocity analysis, right. So basically some small revision I will be doing here, so that everyone will be on the same page, like they can understand how to start a question of velocity analysis whenever we have to use the relative concept method, where we need to draw what? Velocity diagrams, right? So let me help you out. In that case, the simple process I will tell you, okay, and directly we'll enter into the questions. Right, see. So as I told you, let's suppose this is any mechanism we are having. Okay, consider this as a mechanism. Let's suppose this is A, B, C and D. And I've told you the next step is what? You need to draw the velocity vector in the configuration diagram itself. Okay, so if I have to draw the velocity vector of B, okay, assuming AB is rotating clockwise, so B with respect to A velocity vector will be perpendicular to link AB, right? In a similar way, velocity of C with respect to link BC will be perpendicular to it. Okay, on both the sides I have drawn because I don't know where will be the direction. In a similar way, velocity vector of C with respect to D will be perpendicular to it. Okay, I have drawn on both the sides. Again, we don't know the direction or sense of rotation. That's why both the sides I have drawn. Once you have drawn all the velocity vectors, this is C with respect to B, this is C with respect to D. All velocity vectors you have drawn. Second step is just mark the fixed points. Fixed points means this A and D. These are the fixed points, right? So this is the fixed point A and D. I will mark first of all, right? B with respect to A velocity. See, directly I will draw it. This is the point B I got. Because what will happen? They will provide the angular velocity of AB, right? They will provide the AB distance also, dimension also they will give. So velocity of B with respect to A directly we can calculate, right? No, mechanical world, just a small 5-minute revision I will be doing. Then we will come up with the numericals. This session completely numerical we are going to discuss. Okay. So just a revision for those who have not attended the last session. A small revision it will be there. Just it will take 5 minutes. Right. So fixed point I have mentioned. So this is the B point, I got it because this is the velocity vector B with respect to A. Now C with respect to B, this vector I will draw because the reference point B is available. Directly I will draw it like this. Then C with respect to D. D point is available for this velocity vector. I will draw it like this. So both the points are, both the lines vector are meeting at this point. So it becomes a point C. Right. So that's how we will be able to draw our velocity diagram very easily. Very easily we will be able to draw. And if you see, this is the velocity vector of B with respect to A. This is C with respect to B, and this is C with respect to D. Like this it will be there. Is it clear? I hope this basic understanding of how to draw a velocity diagram, all the steps, all the procedure, is it clear? Now we will enter into the numerical and we will start with that numerical that I have given in the last class. Right? Okay. So all the steps are clear. Now we can move to the next slide. Yes, this was the question asked in GATE 2019, right? So we'll be solving this question. First of all, I will give you 2 minutes for this particular question. Please mention your answers in the chat box, guys, everyone. I will give you 2 minutes for this question. It is a very easy question, right? Okay. Two minutes for this particular question. Everyone, please try to attempt this particular question. 2 minutes I have given for this particular question, which is more than sufficient, right? You can easily solve. If you have clearly understood how to draw a velocity diagram. Do it, everyone, fast. Last 1 minute for this particular question. Option D you are getting, mechanical world. Yes, your answer is correct. Option D is correct answer. We'll wait for other students also. Can you tell me what kind of velocity diagram you got? Can you please mention in the chat box what is the shape of a velocity diagram? Is it a triangle? Is it a triangle or rectangle or a straight line? What is the shape of a velocity diagram that you have drawn here? Please mention in the chat box. So time over here. Okay, now see, we'll see the solution here. So first of all, this diagram we have to look first. Is it triangle? Okay, okay. Let me help you out in this case. Okay. So this is the velocity configuration diagram actually. 10 radian per second for AB it is given. So I can write the velocity vector of B with respect to A. It will be like this. Perpendicular to link AB. Perpendicular to the link AB it will be like this. This is velocity vector of B with respect to A. Yes or no? Now, velocity vector of C with respect to B will be perpendicular to link BC. So, I will draw it like this. And velocity vector of C with respect to D will be like this. Simple logic that you need to understand that it is perpendicular to this one and it is perpendicular to this one. Right? Done? So, all the velocity vectors I have drawn. Let me write down the name also. This is velocity vector of C with respect to B. This is velocity vector of C with respect to D. Now, both the all the velocity vectors I have mentioned here. Okay, all the velocity vectors I have mentioned. Now, what I need to do? The very first step, straight line. Okay, now see, the very first step is mention the fixed points. A comma D. Fixed points. Now, velocity vector B with respect to A. This calculation you can easily do. It will be what? AB multiplied by omega AB. Right? Now, if you see in this question, all the dimensions has been given, right? Okay, fine. So, some value it will be having, but that value, that velocity vector is horizontal. Why? Because it is perpendicular, na? Perpendicular is there. This link AB. Link AB is perpendicular. Okay. On that, the velocity vector will be like this. So, this line will be horizontal. Clear? So, that's why horizontal line we need to draw. Now, so this point will be B. This point will be B. Now, velocity vector of point C with respect to B. Velocity vector of point C with respect to B is having this, is having what? This kind of vector, having this direction. Directly I will place it here. Directly I will place it here. Like this. Okay, fine. Then velocity of C with respect to D, again horizontal line. But from which point I need to draw? Reference point is D. For this C with respect to D, D is a reference point. For C with respect to B, B was a reference point. That's why I have drawn a vector like this for C with respect to B. Now C with respect to D, D is a reference point. Again from here I will draw one line which is going to intersect, okay, which is going to intersect the B with respect to B, C with respect to B vector at this point only. So this point is nothing but C only. So please try to understand here, everyone. This vector line I have drawn for C with respect to B. This one I have drawn for C with respect to D. Both are going to intersect at this particular point. Both are going to intersect at this particular point. Is this diagram is clear to everyone? Yes or no? Tell me. Is the diagram is clear? This velocity diagram? Is it clear, everyone? Okay. See. Now, velocity diagram you have drawn. Now, second step is to understand what are the velocity vector. First of all, this velocity vector B with respect to A and velocity vector C with respect to D. If you see, both are equal. Both are equal. So, both are equal means how we will write it? We will be writing like this. Velocity vector of B with respect to A equals to velocity vector of C with respect to D. So, AB multiplied by omega AB, and here it will be CD multiplied by omega CD. Okay, all the dimensions are given. We can directly put all those values here and we will get the answer. Yes or no? Fine. Okay. AB, what was the AB value? AB value is given as 5 centimeter. Omega AB was given as 10 centimeter. And CD value was given as 2 centimeter. So, omega CD answer will be 25 radian per second. That will be the correct answer. And if you look at the options here, D, 25 is the correct answer. 25 is the correct answer here for this particular question. Tell me, is it clear how we have how I have solved this question? All the steps is clear. How we have drawn this velocity diagram with the help of configuration diagram. All the velocity vectors I have shown. Clear? Done? Okay. So 25 radian per second is the answer here. This is the answer, which is what they are asking. Now, in this particular problem, one more important detail that you want to understand here. Okay, that is what very important, because in future that might come in your gate examination. Right? So, what was that? This was the configuration diagram, vectors I have drawn, and then velocity diagram. Velocity diagram is understood, right? Everyone is clear about it. Can you tell me what is the velocity of B with respect to C? What is the velocity of B with respect to C in this case? Diagram बनाने में problem होता है. Yes, I know there will be some difficulties, but if you strictly follow the procedure, you will never face a difficulty. You have to follow the procedure. Mechanical world, please understand this thing. What is the procedure? Whatever the configuration is given, in that configuration you just need to draw correct velocity vectors. On the given configuration diagram, you need to draw correct velocity vectors. If you have drawn correct velocity vectors, then all the velocity vectors you need to put it here. For that, first point is mention the fixed points. Then one by one, all the vectors you have to show. And finally, you will get the velocity diagram. Right? So, in this case of velocity diagram case, you need to follow the fixed procedures, steps you have to follow. Right? and then all the questions, in all questions you can easily draw velocity diagram. Okay. Now tell me what will be the answer of this velocity of B with respect to C. What will be the answer? What will be the answer of velocity vector of point B with respect to C? Yes, definitely. If you try again, you will understand. There are 2-3 more problems that we are going to discuss here. And I will guarantee you one thing, if you solve those questions with me in this particular lecture, you will understand all the steps of velocity diagram. All the 2-3 questions are there. We will be solving with velocity diagram only. Okay. Later on, eye center also we will be using, but right now we have to focus on velocity diagram approach. Now tell me the answer of this one. I am waiting for your answer. B with respect to C. B with respect to C will be what? And for understanding what will be the answer, you have to focus on the velocity diagram. And when you will focus on velocity diagram, you will understand B and C are the same coincident point. In the diagram, B and C are the coincident point. Okay, and this is what the velocity diagram. If they are coincident, what will be the velocity? 0. Are you getting the point? Velocity will be 0. And when it is 0, it means BC, the length BC multiplied by omega BC equals to 0. As BC length cannot be 0, what will happen? Omega BC will be 0. Yes, 0. So what is the conclusion here? What will be the conclusion? Conclusion is link BC is having 0 angular velocity. When it is having 0 angular velocity, it simply means translation is occurring at that particular moment. It is not always it is having 0. Omega 0 for this particular moment, for this particular instant of time, omega is 0. Right, so I hope this information everyone will be able to remember. Okay, I will mark it here as a note point here. Next, as a note point we will be writing. From velocity diagram, we can say velocity vector of B with respect to C is 0. If it is 0, as I know, B with respect to C will be written as link BC multiplied by omega of BC. As it is 0, okay, as we know that BC value cannot be 0, so what happens? Omega BC will be 0. Is it clear? Omega BC 0. 0 angular velocity. Clear? When angular velocity is 0, it means what kind of motion it will be performing? Pure translation. Simple. I hope everyone got the point here. Is it clear? Now, we'll move to the next problem. Again, similar kind of problem was asked in the GATE examination, GATE 2011. Previous problem from the GATE 2019. This question is from GATE 2011. Similar kind of question. Okay. Again, I'm telling you within 2 minutes you should be able to solve this question. So let me give you the time also. I will give 2 minutes. That is more than sufficient. Again, very easy problem. Same question. Only what you need to do, draw the correct velocity diagram based on the steps that I have told you. Okay, everyone should try and tell me your answers. Do it fast. Last 1 minute. Last 1 minute for this particular problem, guys. Last 10 seconds. Tell me, what will be your answer in the chat box? Again, please understand, this question is again similar to the question that we have solved here. GATE 2019. First, it was asked in 2011. It was asked first of all in 2011. Then they were asked in 2019. Similar kind of problem, right? Again. So, see how we are going to solve. Let me just first take the screenshot of this diagram. Now, velocity vectors I will be showing in the configuration diagram. As it is rotating anti-clockwise, velocity vector of B with respect to A will be like this. As it is vertical, it will be horizontal. Now, C with respect to B, perpendicular to link, BC it will be there, right? Like this. Then velocity of C with respect to D will be again a horizontal. So like that we will mention the velocities. This is velocity of B with respect to A. This is velocity of C with respect to B. This is velocity of C with respect to D, like this. All the velocity vectors I've mentioned in the configuration diagram. Then what is the step? First step is what? Draw all velocity vectors in a configuration diagram. Step number 2, consider the fixed points. So considering the fixed point A, D, these are the fixed points. Now B with respect to A, omega is given. So how you will be going to write B with respect to A? It will be written as AB multiplied by omega AB, like this, right? Okay, fine. Now it will be in a horizontal direction like this. So somewhere here you will get B point. Now as I got the B point here, now velocity vector of C with respect to B is having this direction. Same vector I will put and directly place it here, like this, right? Now C with respect to D, again horizontal, but the reference point is D. So from here I will draw. So when you will start drawing it from here, you will understand that it will again meet it here. So the point C will be here itself. Same, yes, exactly same velocity diagram will be there. Yes, correct, absolutely correct. Okay. So this was the velocity vector of C with respect to B. But what will be the answer? Tell me, what is your answer? Same, what we are going to write here, B with respect to A and C with respect to D. Both are equal. B with respect to A equals to C with respect to D. So AB multiplied by omega AB, CD multiplied by omega CD. And if you see the question here, they have given one relation. Link CD is 1.5 times of link AB. Okay. So AB, I will write it as it is. Omega AB was given as 1 radian per second. CD is 1.5 times of AB multiplied by omega CD. So omega CD, you will be getting 1 by 1.5, which can also be written as 2 by 3 radian per second. Okay, you will be getting distance. Okay, you have not seen this data. So link CD is 1.5 times of link AB. They have given the relation between CD link length and AB link length. So CD is 1.5 times of link CD. Right. So finally answer will be what? Answer will be 2 by 3. Answer is 2 by 3 because answer is 1 by 1.5. Answer is 1 by 1.5. Okay. So that's why answer will be 2 by 3 here. This will be the correct answer. I hope, is it clear? Fine. Now, very easy problem. Now coming to the next problem. Yes, this is what a very good problem. Here, apart from drawing the correct velocity diagram, you need to be very good at the geometry part also. You need to be good at the angles, how to consider the angles between different vector lines. Some basic geometry part should be good. Okay. If you don't have that much basic geometrical basic concepts, then definitely you are going to suffer a lot in these problems, in such kind of problems, right? So again I am telling you, in simple mechanism or starting part of the simple mechanisms, you need some of the basics of geometry part also, right? That you will understand when you will solve the questions that came in GATE examination. You will understand there is some part or some role of geometry which is what required in order to solve the questions. Right. Now coming back to this question. Okay. Yes, your answer is correct. Option D is correct answer. That is 2 by 3, 0.66. But they have mentioned 2 by 3, so we will write it like this. Now see this particular question very carefully. The input link O2P. O2P is the input link of a 4-bar linkage rotated at 2 radian per second. So let me just mention the given data here. Omega O2P is given as 2 radian per second. Okay, O2P is given as 2 radian per second, omega, angular velocity. Counterclockwise, okay, CCW counterclockwise, and it is mentioned in the diagram also, no issue. Angular velocity of the coupler PQ, angular velocity of coupler PQ, I have told you what is coupler also. So PQ they are asking, but remember, but at an instant when angle O4 O2P is 180 degree. We don't have to find out for this position. We have to find out when this particular angle is 180 degree. Okay, let me use different color here. When the angle is 180 degree, when this theta angle becomes 180 degree, for that condition we need to find out angular velocity of link PQ. So the very first step here is we need to draw correct configuration diagram. Correct configuration diagram means we need to draw this configuration diagram based on this condition. Based on this condition, I need to draw configuration diagram. Once it is drawn, then we will show the velocity vector. Then we will draw the velocity diagram, right? So let us try to solve this question, guys. Let us try to solve this one, okay? So here the diagram is there. Now I will draw the diagram again. Okay. So this angle they have told us we have to take it 180 degree. Now see, this is O2, this is O4, this is P, this is Q, and O2, O4 is fixed, right? Okay, so we have drawn the correct configuration diagram. Okay, correct configuration diagram we have mentioned. Angle becomes 180 degree as per the information given. Okay, this was the condition for this configuration diagram. For that configuration we have drawn the correct diagram, correct configuration diagram we have drawn. Apart from that, dimensions are given. Dimensions are given, so let us mention those dimensions also. O2P and O2O4 have same dimension, that is A. Let me mention it here. Dimension A, dimension A, this is root 2A, dimension root 2A, because PQ and QO4, PQ and QO4 is root 2A. Okay, fine. This is the configuration diagram. Next step is to mention the velocity vector. Next step is what? Show the correct velocity vectors here. Okay, velocity vectors I will show. Okay, for O2P 2 radian per second they have given, right? So obviously velocity vector of P with respect to O2 will be like this, right? Velocity vector of P with respect to O2. Okay, fine. Then P with respect to O2. Velocity of point P with respect to O2. And one more thing, it will be what? It will be perpendicular to link PO2 or O2P. Velocity vector will be perpendicular, right, to O2P, perpendicular to the link always. Velocity vector will be always perpendicular to the link. Fine. So P with respect to O2 I have mentioned. Now for Q with respect to P, perpendicular to PQ I will mention. Perpendicular to PQ I will mention. But before that, I've told you na, basic geometry part you need to be very careful in simple mechanism. So that part you need to understand. Root 2A. This is a isosceles triangle. Yes or no? It is a isosceles triangle. So this angle and this angle will be equal. This angle and this angle will be equal. But what will be the angle? How I can get the answer? What will be the angle? Simple logic. Can you calculate this angle? Yes, I can calculate. How? See. Let's suppose this is theta. So this cos theta I can write. Base upon hypotenuse. Let us consider a right angle triangle like this. Consider a right angle triangle PQO2 is a right angle triangle. In that right angle triangle, theta is there. So base will be this one, hypotenuse one will be this one, base and hypotenuse, and this is what perpendicular. So base upon hypotenuse will be like this. So from here you will understand cos theta answer is 1 by root 2, which means theta value will be 45 degree. Is this information is clear? So that's why I'm telling basic geometry part is what required, very, very important. Done? So cos theta is equal to A by root 2A. Finally, theta value is 45. We got it. Fine. So instead of writing this theta, I will mention 45 degree as the answer here. Is it for, if when it is 45, this one will be also 45. And this is 45, 45, this angle will be 90 degree. This information is very, very important. Before drawing all other velocity vector, this 45 and this 90 degree information is very, very important. If anyone misses this information, definitely he or she will be going to do mistake. Definitely mistake will happen. If you don't understand this 45 degree isosceles triangle, this angle will be 90 degree if this is 45. If basic geometrical mistakes if you are doing, definitely you are not able to get the answer. That's why I told you basics of geometry is what very, very important in such questions. And whenever we are using velocity diagram, in that case it is what always required. Okay. Now we can easily draw the vectors, velocity vectors. As P with respect to O2 is a velocity vector perpendicular to link PO2 or O2P. In a similar way, velocity vector of Q with respect to P will be perpendicular to link PQ. And when I will draw a vector perpendicular to link PQ, it will be along this line. It will be along this line. Remember, because PQ and QO4 is perpendicular to each other, so that vector will also be perpendicular. Okay, so that vector is perpendicular to PQ. That is fine as far as our concept is there. Okay, based on our concept, this one will be perpendicular to each other. Fine. Okay, but that vector is along QO4. That point you should remember. This vector will be along QO4. In a similar manner, when I will write the vector, I will show the vector of Q with respect to O4. Vector of point Q with respect to O4 I will show. What I need to do? I need to draw a vector which will be perpendicular to QO4. Perpendicular to this one will be obviously along PQ. Right? Like this. So let me write it here. This is Q O4. This is Q with respect to P. Done. All the velocity vectors I have shown it here. Now next step is mention the fixed points O2, O4 and then mention one by one all the velocity vectors. And then you will be getting what? Velocity diagram. Okay. Now let us draw the velocity diagram here. O2, O4. O2, O4 I have taken. First velocity vector P with respect to O2 I will write, because for that angular velocity was given. What was the angular velocity? 2 radian per second. Okay. Vertically downward. Okay. Let me use this vertical line here. Vertically downward. Done. So I have drawn little bit on a larger scale, because so that you can easily understand. So that point will be what? Point P. Okay, because we are writing velocity of P with respect to O2 point. P with respect to O2. O2 was the reference point. Reference point is available from that velocity vector I have drawn, vertically downward. Done. Next vector I will draw Q with respect to P. P point we have figured out. Now Q with respect to P. This vector will be drawn from this point P, like this. Same direction I need to maintain. Same direction of Q with respect to P that I have shown in this configuration diagram. That same direction I need to maintain it here also in the velocity diagram. Is it clear? Same direction I need to maintain it here. Okay, fine. Now, while doing so, you need to understand what will be the angle of Q with respect to P from the vertical. Can anyone tell me? What will be the angle of Q with respect to P from the vertical? So, as Q with respect to P is this line, from the vertical, how much angle it will be having? Again 45. Now, you will say, sir, why you are asking from the vertical? Because vertical line is there, na? This line I have drawn. This line I have drawn for P with respect to O2. So, from P with respect to O2 vertical line, what will be this vector is having angle? How much angle this vector is having from the vertical? How much angle Q with respect to P vector, this vector is having from the vertical? 45. So, now I can easily draw this vector without having any confusion regarding the angles. So, it will be like this. Okay. So, this angle will be 45. It is understood. Yes, obviously 45. Now, another velocity vector Q with respect to O4. O4 is the reference point available here. This line I need to place it here directly and maintain same direction. Okay. So, like this. Like this. Is it clear? Now, I will mention all the names here. First of all, I have mentioned this is a Q. Q with respect to P. And this was velocity vector of Q with respect to O4. Both the vectors are intersecting at this point. So, this is the point Q. This is the point Q. Now, understand this angle and this angle is 45 and this angle is 90 degree. Right? Angles are also clear. Fine. Now, what we can do here, I will mention the velocity vectors. This vector is represented by P with respect to O2. This is represented by Q with respect to P, and this is represented by Q with respect to O4. Q with respect to O4. Done. And what was the question? Please understand, they are asking PQ. They are asking the PQ angular velocity, right? Now, as far as this triangle, this is the 90 degree. Can I write for this triangle, as this is a right angle triangle, can I write here? Please carefully observe, everyone. Can I write the velocity vector P with respect to O2, okay, and velocity vector Q with respect to P? Is there any relation based on this right angle triangle? Based on this right angle triangle, can I write velocity of Q with respect to P as velocity of P with respect to O2 cos 45? Tell me, can I write it like this? Is it correct? Simple, na? Right angle triangle. This is a right angle triangle. So, this base I can write as a cos component of this inclined line. Cos component of P with respect to O2 will become velocity of Q with respect to P. Q with respect to P is the cos component of P with respect to O2. That's what I have written here. Using this relation, we will get the answer very easily. Okay. So, this is our velocity diagram. So, in the next page, we will solve it further. Velocity of Q. P with respect to O2 cos 45. Okay, Q with respect to P will be QP multiplied by omega PQ, which was the actual question they are asking. Angular velocity of link PQ, right? P with respect to O2 is PO2 multiplied by omega PO2 cos 45 is 1 by root 2. Now, what are the values? O2P value is A, okay, O2P value is A and QP value is root 2A, okay. This is root 2A multiplied by, what was the angular velocity given? Answer 2. This is 2. This is A. Okay. Sorry, not for PQ. It is given for O2P. PQ we need to find out. Omega PQ, that is what we need to find out, right? And PO2 or O2P given as 2, root 2, like this, right? So now from here, as AA will get cancelled out, omega PQ, this 2 will get cancelled out by root 2, so it becomes root 2 only. Okay, so what will be the answer? What will be your answer? Tell me, there are 4 options available. What will be your answer here finally? Option C, 2 root 2. No. Just again check the calculation. This 2 will get cancelled out by root 2, so it will become only root 2. Root 2 will get cancelled out. AA will get cancelled out. 1 radian per second will be the answer. One radian per second will be the answer. Please cross check again. So, how we have to solve this question? First, make a correct configuration diagram. Once you have done the correct configuration diagram, draw the all velocity vectors. Once velocity vector is done, after that what you need to do? Draw the velocity diagram. Is it correct? Okay, fine. 1 is the correct answer. Okay, done. So, now tell me, are you able to draw a correct velocity diagram? Yes or no? Are all the steps, can you tell me, now all the steps of velocity diagram, is it clear? Yes, superb, great. Now, one more mechanism I will be taking here, one more, that is our single cylinder crank mechanism. For this also I will be drawing a velocity diagram. Okay, so let us draw the velocity diagram here for this one also. Okay. Let us first consider this omega. Okay. This is point A, this is point B, this point is C, and this is what? D. The cylinder is fixed, okay. Okay, so this is C, this is A, this is B, and this is D. So all the points I have mentioned, okay, one by one. Now what we need to do? We need to draw simply correct velocity vectors. I need to represent correct velocity vectors, right? Okay. So first of all, B with respect to A, it will be perpendicular to link AB. It will be perpendicular to link AB. B with respect to A I have drawn, and it will be perpendicular to link AB. Fine, done. Now next vector I am going to draw for C with respect to B, and one thing is sure that it will be perpendicular Okay, it will be perpendicular to link AB, link BC, sorry, link BC. It will be perpendicular to link BC. So this vector we have drawn for velocity of point C with respect to B. Velocity vector of point C with respect to B we have drawn. Now one more velocity vector, that is C, that is this C with respect to D. Velocity vector of link C with respect to D. C is what? The slider, which is what? Having a simple sliding motion with respect to cylinder. So what will be the velocity vector of link C with respect to D? Tell me, in which direction I have to draw? In which direction I should draw it? The vector C with respect to D. Whenever we are writing C with respect to D, please understand very basic point. We need to observe the motion of link C with respect to D. The motion of link C with respect to D is in a horizontal line because it is sliding, it is reciprocating. So horizontal line it will be having the velocity vector. Here B is what? Rotating with respect to A, that's why velocity vector perpendicular to link. So basic point is we need to understand the motion of a link with respect to another link. Motion of a link with respect to another link. And for that we need to know how both the links are get connected. How both the links are get connected, that is what very important point. So I'm telling you again and again guys, link, basically we need to know different types of link. Apart from that, how different links are getting connected with each other based on their relative motion, based on their surface contact or point contact, based on the closure. Different classification of contacts, joints also it should be clear. Different kinematic joint should be clear, right? So C with respect to B is perpendicular to link BC, as this vector is perpendicular to this one. Okay, because this is the point you need to understand, because this is a turning pair between link BC and link, this is what? Connecting rod and the slider. Okay, and this C, which is what? Slider, is moving with respect to cylinder in a horizontal line. So vector we have to draw it. Okay, vector we need to draw it. Okay, in the horizontal direction like this. So dotted line I am drawing just. Okay. Now coming back to the what? Velocity diagram. For that, first fixed points A comma D. A comma D. A comma D I have mentioned. Fine. In A comma D, first of all, B with respect to A I have to mention. Okay. B with respect to A. B with respect to A. Okay, take this one only. So in this direction, right? So let us draw it in this direction. So this point will be B. Okay, done. Now velocity vector of C with respect to B is having this direction. We will take this direction and directly place it here. Directly place it here. Okay. C with respect to B. This direction I have to take and directly place it here, because B is the reference point is available. Now done. Is it also done? Now velocity vector of C with respect to D is having this horizontal line. Why it is horizontal? Because C, that is slider or piston, is moving in a horizontal direction, right, with respect to cylinder D. So let us draw that one also, the horizontal line with respect to point D. Fine, like this. So all the points I have drawn, all the vectors I have drawn properly. Now next thing is, this point will be point C. This is point C. Okay, fine. Now let us mention all the velocity vectors here. This was the velocity vector of C with respect to B. This was the velocity vector of C with respect to D. So the intersecting point will be C. Okay. So this is what the velocity diagram of a single slider crank mechanism. Velocity diagram. Done. And we will mention the velocity names also. This is B with respect to A. Okay. This is C with respect to D. Okay. And this is C with respect to B. This is C with respect to B, this is C with respect to D, and this is B with respect to A. Always remember, arrow will be towards the point for which we are writing from the reference point. That is B with respect to A. Towards B, A was the reference point. Towards C, D was the reference point. Towards C, B was the reference point, like that. I hope this diagram, velocity diagram of a single slider crank mechanism, is it clear? Is it clear to everyone? Because we have seen almost 4 cases, right? 4-bar mechanism, yesterday also we have discussed so many velocity diagrams. We have discussed the basic fundamentals of motions also. Types of motion we have discussed. We have translation, rotation and T plus R. General plane motion we have discussed. All the basics we have discussed. Now we have come to this point that we can easily draw the velocity diagram and we can easily calculate different velocities of different length. Okay, different velocities we are able to calculate for different lengths, right? Very basic thing. Done. Superb. Great. Now in the next lecture, that is on tomorrow, we are going to start with the next method. Next method is what? Eye center method. And I will tell you this point, that when you will learn the eye center method, you will definitely always use eye center method, because there is a point that it will take less time. It will take less time compared to this particular velocity diagram method. And all the numericals you can easily solve with the eye center method also. But this method is also available. If you are convenient, you are having comfortability in using this method, you can use it. But one thing I can tell you with so much surety, that eye center method you will like most, because it is less time consuming and easily you will be getting the answer. Okay. So in tomorrow's lecture, eye center approach of velocity analysis I will be doing. So please attend tomorrow's session also on the eye center method, and we will see, we will solve this question that we have solved now, this one. Then you can tell me, this question we will solve with eye center method also, and then you can only tell me, sir, which method is easy or which method is more suitable for us for competitive examination. For competitive examination, which method is what good? Because in competitive examination, what is the main criteria? We need to solve the question correctly in a less time. Okay. So thank you so much everyone. Tomorrow's session, please attend it. Okay, everyone should attend tomorrow's sessions, because tomorrow's session will be on eye center approach. Very, very important for your GATE examination. Right. So thank you so much. We'll meet you tomorrow again, same timing. Thank you.